Hi students, I am trying out my new toys as I make this screencast, so hopefully it will go well and maybe I'll even be able to write a little bit neater. We'll see. You guys will have to give me feedback if you find this more difficult to view or easier to view or whatever. The point of this screencast is to give you a little bit of assistance with the exploration assignment about terminating and repeating decimals. So within this third module, you are supposed to print out this assignment and work on it. And you might not get it perfect, but I want you to get as close to a complete understanding as possible. After you complete this assignment, you're going to do 2 discussion prompts. So this assignment that I'm going to get you started on here is not graded. This is just for your own use. Doesn't mean don't do it, because it's really important, but it's not graded. You do 2 discussion prompts based on this assignment, and those are graded. And in those discussion prompts, you are supposed to answer questions which will let me know how much you learned while doing this assignment. After that, you will see some screencasts that will go over the information simply to make sure that you understand it completely, so everybody's on the same page. So this is kind of my way of doing teaching through problem solving, which you learned about in the last module. So I am giving you information. I'm trying to guide you through figuring out how to do something on your own. You're going to answer questions in those discussion prompts, which lets me know how well you did. But then there are videos / screencasts that will come after that to make sure that everybody is on the same page. And then you will be doing some practice problems after that, which you'll find in a Wiley Plus assignment. Okay, so enough. So we want to talk about taking fractions and turning them into decimals. And so I have a calculator sitting here in front of me. But essentially, we are looking at some fractions here. So like if I look at this 3/8, try that again. So if I look at the 3/8, if I wanted to turn that into a decimal, most people would just turn to their calculator, do 3, divide by 8, and say, hey, that is equal to 0.375, right? But I want you to come up with a way to change fractions to decimals without using your calculator to divide. You might still use your calculator, but I don't want you dividing the numerator by the denominator, okay? So on these first problems here, what you want to do is make factor trees if necessary, because you are, oh, actually I'm on a different page. So on these problems here, you're just going to actually use your calculator. So it's just getting you used to the fact that some fractions terminate, some fractions repeat. So these are terminating. So 17 over 25, using my calculator, and I get 0.68, right? The other two you could do the same. Now I'll come down here. I'm going to do 35 over 42, so that's 35 divided by 42. And I get 0.83, and then it's 3, 3, 3, and it keeps going and going, right? The correct way to write this is 0.83 repeating. So you put a bar over top of the part that is going to repeat. All right, I'm going to go to the next. Okay, so now comes the part where I'm going to, or you're supposed to figure out a way to do these problems without the division. So what it tells you is to rewrite each one of these fractions, and you are going to leave the numerator alone. So the top number, nothing. Bottom number, you are going to write its prime factors. And I did one for you. So 3/8 equals 3 over 2 times 2 times 2. So I will do 221 over 400. So if you don't remember, most people, if I say or show a factor tree, then they remember how to do this. To get the prime factors, one way to do it is a factor tree. So 400, you can break it any way you want. because in the end it's going to turn out the same. But I'll do 4 times 100 because that's a pretty obvious factors. The 4s break into 2 times 2. The 100 breaks into 25 and 4. The 25 is a 5 and a 5, and the 4 is a 2 and a 2. And you stop at this point. If the only thing that you could do is, break it down a little bit more and use a 1, then you don't do it anymore. So 221 over 400, you would want to write it like this on your paper. So I've got 2, how many do I have? 1, 2, 3, 4. 3. Remember, multiplication is commutative, so I can write these in any order I want. And I've got 2 5s. Right? So you would want to do the same process for the 17 and the 125. All right, these guys here, I'm telling you, are repeating decimals. You can check it on your calculator to know these are terminating and these are repeating. These guys are repeating. So I'll do one of these for you. I'll do this 26 over 70. Okay, so I'm going to leave the 26 alone. I'm going to work with the 70. So again, I'm going to do, hey, that's 7 and 10. I could have done 35 and 2, and I would have gotten to the same place. I just happened to start with 7 and 10. And that's 5, and that's 2. So this is rewritten as 26 over 7 times 5 times 2. All right, so then you want to do the same thing for these 3 fractions. Go back and do these 2. All right, so number 4 is really critical. All right. Giving you a hint here, but I'm not going to give you the answer. So these are conjectures. A fraction will terminate as a decimal if the prime factorization of the denominator, so that means we're looking at the numbers in the denominators, contains only the numbers, and there's going to be 2 numbers that get filled in here. You need to come up with those numbers are. All right. Should be pretty obvious. Once you have all of the prime factors written down, you're only going to see 2 numbers that are showing up. That's what's going to go here. And then a fraction will repeat as a decimal if the prime factorization of the denominator contains any number that is not. All right, so that's the important part here. Any number that is not a. The answers to this are going to be identical to the answers for this, okay? So you're going to come up with the 2 numbers here, then you're going to come up with the 2 numbers here. All right, then the next thing you're going to do is start working on, okay, how can I write fractions as decimals without dividing? All right, so 75 over 100, yes, you could use your calculator and do 75 divided by 100, but you also can look at this and say, hey, 75 over 100 is 75 hundredths. And the correct way to read 75 hundredths out loud is, or this 0.75 out loud is as 75 hundredths. All right, similarly, 4 tenths is equivalent, right, to 0.4 because this is 4 tenths. And this is 368 thousandths. That's exactly what this decimal is when you read it aloud. It's 368 thousandths. Okay, so if I write 22 over 100, that's 22 hundredths. And remember, this is the tenths spot. And this is the hundredths spot. Yep. All right. So it gets named 22 hundredths. It's the last spot that the digit is in is how you name those decimals. All right. So problem is if I have something like 22 over 25, I can say that's 22/25, but I can't record that as a decimal directly because when I do decimals, they're either tenths, hundreds, thousandths, and so on. And this is 22/25, okay? So the next thing that you're supposed to do, and again, this is exploration so that you can try to figure something out, is to write these fractions in prime factorization. So I'm doing 368, and I'm going to do over 1,000. So fraction, or factor tree again. So this would be 100 times 10, which would be 5 and 2. And that would be 25 and 4. That would be 2 and 2. That would be 5 and 5. So it looks like I have 1, 2, 3 5s. I'll put my multiplication between there. And then 3 2s. All right, so you want to do the same thing for these other 3 fractions. And then you're going to come down. And you're going to say each of these fractions terminates, so we only see, these are the numbers from before, and then you're going to keep moving on through here, okay? So the number of 5s and 2s is, and you're going to say what do you notice about the quantity of? I'll give you that hint here. Okay. All right. So then you're going to keep going through, and then you're going to finish off showing your new process. Okay. So I'm going to stop here. What I want you to do is work through this paper using some of these hints, some of this helpful things I've done. And I want you to do the very best that you can on those discussion prompts. I think the first of the 2 discussion prompts everyone should get. I think the second one might be pretty tough. We might have some people who get it, some people who don't. But I want everybody to give it a shot. Please remember that second one is a 10-point discussion prompt that in the end is not really going to contribute towards your grade. Also remember that after that second discussion prompt, you are going to look at some videos that are going to spell it out for you. They're going to say, hey, here's exactly how you can tell if a fraction terminates or repeats. And if you know it terminates, this is exactly the procedure that you can use. All right, so I'm wanting you to try to figure out that procedure on your own. When I use this assignment in my face-to-face classes, you know, they kind of have me circulating around so I can kind of help them over bumps in the road. And I didn't want to not have you guys doing some exploration because I think it's really important. So give it your best shot. I hope this screencast has at least helped a little bit there. And that's it.